Now see, this is question number 2 of paper 620, paper 42, February, March 2024. The elements in group 7 of the periodic table are known as halogens. Halogens can form halide ions. Okay. Identify the halogen with the lowest density at RTP. Lowest density, density increases down the group for every group. So the lowest density would be for the element on the top. So the element on the top of the halogen is fluorine. State the appearance of bromine at RTP, room temperature. So state must be mentioned here. And its color is red brown and it is liquid at room temperature. So we should write red brown liquid as its answer. Use the periodic table to give the symbol of the halogen with the highest atomic number. Down the group, atomic number increases in every group. So the highest atomic number, previously it was acetine, but now it is tennessine, and we have to write only the symbol. So the symbol of this element is tennessine. Deduce the number of occupied electron shells. Occupied electron shells. How many electron shells it has occupied? So remember that tennessine is in period number 7. So period number period number indicate the number of shells. So there are, if period number is 7, so they have 7 occupied electron shells. Now this is the part D of the question number 2. Bromine molecules have covalent bonding. State what is meant by term covalent bonding. So they are asking about the simple definition, and the definition of covalent bonding is that it is a bond due to the shared pair of shared pair of electrons between two atoms. You must mention that it is between two atoms and shared pair of electron. So you will get the full mark. Name one halide ion which bromine molecule can displace. So the top one is fluorine, then chlorine, then bromine, then iodine, and then astatine, and the last one is tennessine. So the reactivity in halogen decreases down the group. So the halogen on the top can oxidize the halide ion below in the group. So iodide, astatide, and tennessite, these all ions can be oxidized. Okay, so bromine can displace these ions from the solution. So we should write any of these. Iodide, it's okay. If you write astatide is also okay. Or if you write tennessite, then it is also okay. So you can write any of these. Explain why bromine can displace the halide ion D2. So as I have already mentioned, that bromine is more reactive than these elements, and reactivity decreases down the group. So we should write because bromine is more reactive than iodine, tennessine, astatine. You can write any of these. This is I2. Okay, better to write in words. Name the halide compound which can be used to detect the presence of water. They're asking about one of the halide compound. So we have learned that this is cobalt 2 chloride. Cobalt 2 chloride. When cobalt 2 chloride, sorry, chloride. When cobalt 2 chloride is in anhydrous form, then it is blue in color. We should mention the word anhydrous here. So the correct word is anhydrous cobalt 2 chloride. 1 mark for writing the anhydrous and 1 mark for chloride. Uh, Question 2, part F. Calcium chloride is an ionic compound. Complete the dot and cross diagram in figure 2.1 for the ions in calcium chloride. Give the charge on each of the ion. We know halogens form monovalent negative ions. So the charge on halide must be -1. And the charge on calcium must be +2 because it belongs to group 2. All the group 2 metals form divalent cation. Now, see what to draw here. Chlorine has atomic number 17. So after gaining 1 electron, there must be 18 electrons. So how many electrons are there? 2 and 8, 18. So we must draw a circle outside and draw the electrons as well. So these are 18 electrons in each chlorine, each chloride. Similarly, here there must be 18 electrons, and better to show one of them as cross. And calcium has atomic number 20 and it has 2 plus charge, so -2. It also has 18 electrons, but show all these 18 electrons in the same way as it is here in the cross. So you must draw in cross because it has lost the electrons, so there would be no other sign for the electron. So in this way, now you will get all the 3 marks. 1 mark for the correct charges, 1 mark for correct number of electrons in calcium, and 1 mark for correct number of electrons in both the chlorides. This is part G of the question number 2. Aqueous lead 2 ions are added to aqueous chloride. A white precipitate of insoluble lead 2 chloride is formed. Name a lead 2 compound which can be used in this reaction. So remember that we are to use a compound of lead that is water soluble. We know all the nitrates are water soluble. So we should write the formula of lead nitrate, or and better to write the word lead to nitrate. And if you use the formula along with it, then it's okay. Lead 2 is this and nitrate is this. It has 1 minus charge, So its charge is written here and its number is written here. So the formula of lead to nitrate is PbNO3, but as they have asked us to name the compound, so better to write lead to nitrate. Write the ionic equation for this reaction. The ionic equation is, because this is the reaction between lead ions and chloride ions, so use lead and chloride in the reactant side, and lead to chloride is the product. So write the formula of the lead to chloride here. For writing the correct equation, there is 1 mark. For balancing, there is 1 mark. And for using correct state symbols, it is 1 mark. So these are in aqueous form as already written here. So this is the hint. And as a student of chemistry, we know that in aqueous, when these ions react in aqueous form, then they form their precipitates, which are insoluble. Then one another insoluble chloride. It is in our syllabus, silver chloride. Again, avoid writing the formula, but you can write the formula along with the name, okay, to save your marks. So this is the way to solve the question, okay.